Good afternoon, everyone. I'm a PhD student named Fujia, and I'm from Butler School of Sustainable Construction, the University College London. And my co-author is Grant Mills and Dr. Weiwei Chen. So in this presentation, I will begin with the background and the motivation for this study, followed by the research gap and objectives, then the methodology and key findings with discussions. So to begin, let's look at why BIM-based VR is relevant for building projects collaboration in AECO projects. As we know, the AECO project's life cycle involves complex multi-stakeholders collaboration across all stages. And in each phase, most coordination is required different professionals. And BIM is a critical tool to support data integration and collaboration workflows and has widely adopted, but BIM platforms alone often lack immersive communication features, especially for non-technical users. This limits stakeholders' engagement in complex or the high-stake discussions. So on the other hand, VR offers an immersive environment that helps to enhance communication, increase user engagement, and strengthen intuitive understanding of spatial information. So by combining BIM with VR, we create an interactive, real-time, data-driven environment that supports multi-user collaboration and more effective decision-making. Well, BIM-based VR shows great potential for enhancing collaboration. A closer look at existing research reveals several important gaps. First, most existing studies focus on the technical priorities or isolated cases applications. Secondly, collaboration is often treated as a secondary concern. And finally, we found that no peer review has systematically studied collaboration-related variants encountered across the AECO life cycle. So there's a clear need for the structure review that focuses on specifically on the collaboration challenges in BIM-based VR systems. And to address this study aims to systematically review the implementation of BIM-based VR technology, focusing on the challenges and barriers during the AECO collaborative process. It seeks to enhance the understanding of existing problems and understanding the existing problems, facilitate their resolution and maximize the potential of BIM-based VR integration to improve the collaboration in the project lifecycle. So to achieve the research objective, we listed 3 sub-research questions to guide the review. First, it's about how are the collaboration challenges in BIM-based VR implementation characterized? And second, during which project activities do these challenges occur and who is affected? And third, what features directions are proposed to overcome this barriers? And this study follows the SLR guideline and align with the PRISMA 2020 framework to ensure the transparency and consistency. We searched 6 major academic databases using a Boolean keyword strategy combining terms like the BIM, VR, and collaboration. The research covered literature in the past 10 years, focusing specifically on the building-related application in the AECO sector. By using the eligibility criteria, this research initially enters 619 papers, and after removing duplicates and unrelated records, we screen titles and abstract to exclude studies in non-building contexts or those not addressing both BIM and VR. Only English, open access, and building-focused papers were kept. And in the end, 36 studies were included. We can see the full process. It's in the PRISMA diagram on the left. Here's a quick overview of the selected studies. we can see that the research on BIM-based VR grew steadily from 2014 to 2022. And among these, most papers were published in automation in construction and buildings. We also checked the citation numbers of each articles to ensure the high quality of what we started. And using the criteria, whether it addressing collaboration variance directly, articles are preliminarily classified as two-part, and the result shows that more than half of the articles just mentioned collaboration variance without clearly precise solutions. For the 20 studies that didn't offer clear solutions, we analyzed their contents and identified 4 main types of collaborative barriers. First, equipment constraints like the limited hardware's performance or the lack of access. The second is about the technical constraints, including issues with integrating advanced technologies, processing large data, or achieving interoperability. Third, user experience and interface, such as poor usability or unintuitive design. And finally, policies and standards, referring to the regulatory or organizational limitations. And this classification was synthesized from both theory and practice and lays the foundation for mapping specific challenges, stakeholders, and technical directions. So here's the result of the 16 solution-oriented studies. Most papers propose framework systems or prototypes aiming to addressing the collaboration variance from a technical perspective. And key focuses including the interoperability and multi-user collaboration. However, most solutions still have one-way data flows like automation and are rarely validated in real-world settings. Other common barriers related to user experience, equipment constraints, and policy, of course, as the workflow issues. Overall, many of these efforts remains at the conceptual or prototype stage, showing the potential but needing further development for practical adoption. Building on the barriers identified earlier, future research on BIM-based VR collaboration should focus on 5 key areas. First, we need multi-user remote collaboration platforms that support the real-time, low-latency interactions. And second, improving the bidirectional data synchronization can ensure seamless automated links between BIM and VR. Third, the hardware accessibility remains critical, and affordable standalone VR device can help to extend adopt on-site. And fourth, advancing integration technologies such as the incorporating the AI, IoT, or the 5G may significantly improve workflow efficiency. Finally, clear workflow standardization can support the repeatable, precise, and a better real-world implementation. These directions reflect a shift from technical exploration to practical, scalable solutions. And to summarize, the key barriers identified fall into 4 categories. Interaction and interoperability are the most critical challenges. Design review and construction management are the most affected stages, and the key stakeholders involved are architects, engineers, contractors, and clients. Our main contribution includes providing a structured classification of collaboration barriers, comparing theoretical and solution-focused studies, and proposing clear research directions to support multi-user collaboration in AECO projects. Finally, limitations of this study include the use of only open access resource and the reliance on the secondary data. These are the key references that shaped our findings. And thank you so much for listening. I'm very happy for any questions and thoughts.